Here, I'm going to show you how to complete the square. So what does it mean to complete the square? Well, to complete the square, means that we're going to write some quadratic, some x squared trinomial as a binomial squared. And that binomial is actually going to be x plus that middle term b divided by 2. So completing the square means that I can write a trinomial quadratic as a binomial squared. So let's see how we're going to go about doing that. Let's say I have the problem x squared plus 8x minus 10. Okay, so when we first start, we ask ourselves, is this factorable? So can I find two numbers that multiply to negative 10 that adds to 8? Okay, well, my only ways to get 10 are 1 and 10. That's not going to get us 8. Or 5 or 2. 5 plus 2, add, subtract. That's not going to get us 8. So no, this is not factorable. So if we have a quadratic that's factorable, that would be our go-to route. But it's not factorable, so we don't have that option. So this is when completing the square might come in handy. So in order to complete the square, I want to be able to write a quadratic trinomial as a binomial squared. So I need to add something to both sides. So since I can't currently factor x squared plus 8x minus 10, I'm going to move the 10 to the other side. So since this is minus 10, I'm going to add 10 to both sides. We have a lovely rule in algebra. I can do whatever I want to one side as long as I do it to the other. So again, all we did was add 10 to both sides. And now we're going to complete the square. So to complete the square, we're going to take our b value and divide it by 2. Well, what is b? B is this middle term. Okay, so b is 8. I'm going to take 8 divided by 2 and square it. Well, 8 divided by 2 is 4. 4 squared is 16. So I'm going to take my quadratic. Left side is 8x squared plus 8x. And I'm going to add what I just found here, which is 16. Now, I can't just add it to one side. I have to also add it to the right side. Now, why do I want to do this? Now that I have completed the square on the left-hand side, well, what two numbers multiply to 16 but add to 8? That actually is 4 and 4. So I can rewrite this quadratic trinomial as x plus 4 squared. So how do I figure out that this number is 4? It's actually the b divided by 2. 8 divided by 2 is 4. What do we have on the right-hand side? 10 plus 16 is 26. And now I can just solve. Well, how do I solve? I need to undo the square if I'm going to find the x, because if this is a quadratic, I should have two answers, unless it's a double root. So to undo the square root, or to undo the square, I'm going to square root both sides. And if I'm taking the square root from a squared, I'm going to end up with positive and negative. Big square root 26. We ask ourselves, do I have any numbers that multiply to get me 26 that are a perfect square? And I do not. So all I can do is subtract 4. So x equals plus or minus negative 4 plus or minus square root 6, 26. Actually, this first one would not be plus minus. So negative 4 plus or minus square root 26. That would represent our two answers. So let's try another one. Completing the square is also good to find vertex form, because again, you're putting it as a binomial squared. And again, vertex form helps us easily find the vertex, that top part, point, or the bottom part of a quadratic. So let's see if we have this quadratic, x squared plus 4x plus 4 equals 25. So the first thing we should do if we're going to complete the square is we move everything over that does not have an x by it, which means we're going to be subtracting 4. Again, why are we subtracting 4? Because it's plus 4 on the left. We want to move it to the right. So inverse operation of adding and subtracting. So we end up with x squared plus 4x equals 21. And now we're going to complete the square. So again, to complete the square, we're looking at our b value. We're looking for b divided by 2 squared. What's our b value? Our b value is 4. Well, 4 divided by 2 is 2 squared. 2 squared is 4. So to complete the square, I'm going to be adding 4 to both sides. Again, whatever I do to one side, I must do to the other. Okay, because I completed the square, that means I can take my b divided by 2. 4 divided by 2 is 2. And again, because the middle sign is positive, the middle sign is positive here. Again, if the middle sign was negative, you would have a negative in the middle of your binomial. 21 plus 4 is 25. So if we wanted to solve, again, we could easily square root both sides. Actually, I'll show you both ways of solving. It asks for vertex form. So vertex form just means that we're going to set it equal to 0. So vertex form would be x plus 2 squared equals, and we would subtract the 25. This would be vertex form if it asks. Here I can easily see that my vertex is opposite inside, so plus 2 would be minus 2, and then we have a negative 25. So that's if it asks for that. But what if it doesn't ask for a vertex form? What if it asks you to solve? So if it asks to solve, from this point, not x squared, x plus 2 squared equals 25. So if it asks us to solve, we would square root, undo the square by square root. You end up with x plus 2 equals, square root of 25 will be plus or minus 5 because we need 2 answers because it's a squared. And then we can subtract 2 from both sides. So again, we have 2 answers. So I have positive 5 minus 2, which would get us 3. And I have negative 5 minus 2, which would get us negative 7. So we'd have 2 answers of 3 and negative 7. I.e. the 2 points where it crosses the x-axis would be 3 and negative 7. Okay, so this shows us how completing the square can be useful, either to find vertex form or in regards to solving when we have a quadratic that is unfactorable. So let's take it up a notch. So if you want a more complex problem, here you go. How do we solve here? 2x squared minus 7x minus 12 equals 0. Well, usually our first step would be, okay, I have my a value is 2 in front of x squared. Can we just divide everything by 2? Well, nope, I don't have that option. So if we're going to complete the square, again, like always, we're going to move our constant negative 12 to the other side. So we're going to add 12 to both sides. So we have 2x squared minus 7x. We're going to leave some space, equals 12. So in order to solve, we need to complete the square, except that my a value is not 1 here. I have a 2x squared. So here I need to distribute out the 2. Well, if I factor out the 2, not distribute out, factor out the 2. If I factor out the 2, I'm left with x squared. If I factor out a 2, I'm actually left with 7/2 inside. And again, I'm not adding or subtracting anything to both sides, so I can keep the right-hand side 12, because again, I'm just rearranging. Now I am ready to complete the square. Again, completing the square would be b over 2 squared. So what's your b value? My b value here is 7/2. And then I'm dividing that by 2, and I'm going to square it. Well, what do? I have a fraction divided by a fraction. Again, a fraction divided by a fraction, we change division into multiplication. And we multiply by the reciprocal. So I change division into multiply. Instead of 2 over 1, I'm going to do 1 over 2. So really I have 7/2 times a half, which is 7/4. And I'm squaring. So I can square the top, square the bottom. 7 squared is 49. And 4 squared is 16. So I told you we were taking this up a notch. So on the left-hand side, I still have 2. I still have on the inside x squared minus 7/2 x. And I just determined that I am adding now 49 over 16 on the inside. Now we got to be careful on this one. Now I added 49 over 16 on the inside, but if I'm adding it on the inside of the parentheses, that number is also being multiplied by 2. Well, if it's being multiplied by 2, that means I'm actually adding double that amount. And if I reduce 16 divided by 2, I actually get 8. So to the right-hand side, I can't just add 49 over 16. I actually need to add 49 over 8. Again, why am I doing that? 49 over 16 has to be multiplied by 2. So 16 divided by 2 means my denominator will be split in half. I have twice as much. So now that I completed the square, I can actually write my answer as a binomial squared. Again, I have x square squared, x squared is x, square root of 49 over 16. Well, square root of 49 is 7, square root of 16 is 4. And notice my middle term is negative, so my middle term is going to be negative here. Have to do a little bit of math on the right-hand side. I need to get a common denominator. So my common denominator, if I multiply everything by 8, right? This would be over 8, this would be over 8. 12 times 8 is going to get you 96. And if we have 96 plus 49, we'll get a total of 145 over 8. Okay, so now to solve, again, my goal is to try to isolate the x. To isolate the x, I then need to divide by 2. Well, dividing by 2, since we have fraction here, is the same as multiplying by 1/2. So here, if I divide by 2, that's the same as multiplying by 1/2. So I end up with x minus 7/4 squared equals 8 times 2 would be 16, so 145 over 16. Now I need to undo the square. To undo the square, I take square root. So x minus 7/4 equals plus minus. Well, square root of 145, I don't have, but square root of 16 is 4. And we're almost done. Now to isolate the x, I simply need to add 7/4 to both sides. So x equals, if I add it to the front, 7/4 plus or minus big square root 145 over 4. And since both of these are over 4, I could simplify my answer as 7 plus or minus square root 145, all of that over 4. So again, this would not have an integer answer. It would have a kind of pretty messy decimal answer, but that's okay. The exact answer would be 7 plus or minus big square root 145 divided by 4. So again, I told you, taking it up a notch. This is about as complex as it gets when you add fractions. You just have to remember you cannot complete the square unless a is 1. So you have to factor out anything that is not 1. But make sure that when you do complete the square, if you add on the inside of the parenthesis, that you have to multiply that by whatever number's on the outside to add to the right-hand side. Okay, so completing the square can be helpful when a quadratic is not factorable.